I've been interested in robots ever since I really saw the first robot. I started building robots when I was 12 years old, and when I saw the first hexapod, I was in middle school. I saw a hexapod in a book, and from the minute I saw it, I knew I wanted to build one of these. And it wasn't until I took a cognitive robotics class here at the University of Arizona, and at that time I actually had a good excuse to spend a lot of time on working on a hexapod. I'm able to make very complex parts using something called a 3D printer made by Dimension. And the way this works is it actually extrudes layer by layer small amounts of plastic. And there are two kinds of plastic. There's a support material and an actual model material. And the support material kind of holds like overhanging structures, so you can really print any complicated shape that you want. And this right here is the femur of the hexapod. And this was made in the printer, and it was made in the printer like this, and the head actually extruded plastic around and filled all the cavities like this. Now the white material here is the support material, and the gray material up here is the actual model material. And again, it was printed like this, and there's so much support material because this is the actual leg, the way that it comes out. And so you can see that you can really make any sort of complex shape with the 3D printer. And these are very rigid pieces that can be used in robotics, casings for other embedded projects. Before the 3D printer, people had to use things like CNC machines, and those you're very limited on. You can only remove so much material out of a chunk. But with a 3D printer, you're really able to make any sort of shape that you want. When I originally started building the hexapod project, it was part of a class project, and I wanted to find a very powerful processor, and one that also used very little power, and also at the same time needed to be in a very small form factor. So I looked around, and I found some motherboards, very small motherboards, in a Pico ITX form factor, but these did not have the performance that I was looking for. I was looking to use the Open Computer Vision, OpenCV libraries. So around the same time in June, I found this FitPC2, which uses an Intel Atom Z530 1.6 GHz processor, and it incorporates hyperthreading. And this completely blew away the other things that I was trying to implement. And when I run OpenCV on this and I do complex optic flow calculations, it performed a lot better than the other processors I was looking for. So the original project started out when I wanted to have the hexapod actually learn how to walk. So I didn't want to program pre-programmed algorithms that move the legs so that I could walk around. I actually wanted it to figure it out on its own. So in order to sense how well it moves around the world, I put a simple webcam, a Logitech webcam on it, and I use OpenCV using optic flow so it could get a sense of orientation. And that was the main reward sensor for reinforcement learning. And I also decided to have some fun with it. I got a standard PlayStation 3 controller and connected it, and it was very easy to use with the Intel Atom processor. You can just connect it very easily, and it really made life easy for getting simple control of the hexapod.